One of the most promising places where the James Webb Space Telescope can find extraterrestrial life is the TRAPPIST-1 system. This star system, located about 40 light-years away from us, has been the focus of intense study in recent years, and for a good reason. In Cycle 1 of observations, a quarter of the telescope's observing time has been dedicated to exoplanets. And 8% of that chunk is for TRAPPIST-1 alone. Astronomers are confident that the first-year observations of this star system will reveal everything from thermal emission, signatures of water, and even signs of life on the planets orbiting TRAPPIST-1. But what makes this planetary system too special to astronomers? Why are they eagerly waiting for the first results of the TRAPPIST-1 system? TRAPPIST-1 is an ultra-cool red dwarf located about 40 light-years away. It has a mass of about 1/10 of our Sun's mass. Although TRAPPIST-1 was first discovered in 1999, it gained widespread attention in 2017, when it was found to be the only known star to host the maximum number of Earth-sized planets in its habitable zone. Initially, 3 planets were discovered in 2016 by a Belgian telescope. Later, Spitzer confirmed the existence of 7 planets in the system after observing it for 1,000 hours. This is a remarkable finding because the number of planets in the TRAPPIST-1 system is close to that in our solar system. But the most exciting aspect of TRAPPIST-1 is not just the number of planets it hosts. Spitzer also measured each planet's mass and radius, allowing scientists to calculate their densities. Surprisingly, the densities of all the planets were found to be very similar to Earth's. This discovery piqued astronomers' interest in studying these exoworlds further. With the potential for these planets to support life, TRAPPIST-1 became a fascinating system that could provide valuable insights into the nature of our universe. All 7 planets in the TRAPPIST-1 system, TRAPPIST-1b, C, D, E, F, G, and H, are tightly packed around their host star. Even the farthest planet, TRAPPIST-1H, orbits at a distance of only 0.062 astronomical units, 6 times closer to its star than Mercury is to the Sun. As a result, all the planets have extremely short orbital periods. For instance, TRAPPIST-1b, the closest planet, takes only 1.9 Earth days to complete one orbit, while TRAPPIST-1H takes about 19 days. Furthermore, astronomers believe that all the planets are tidally locked, which means that one side always faces the star while the other, away from it. Much like the Moon is tidally locked to the Earth. A critical factor that determines a planet's habitability is its host star. TRAPPIST-1 is a red dwarf star with a radius of just 12% that of the Sun, making it slightly larger than Jupiter. The star is also relatively cooler, with a surface temperature of around 2,400 degrees Celsius. This combination of factors means that planets D, E, F, and G are located within the star's habitable zone, where liquid water could exist on the surface of an Earth-like planet. However, habitable zones alone do not guarantee the presence of life, as several other factors also come into play, with atmospheric conditions being one of the most important. To this end, scientists have used the Hubble Space Telescope in recent years to try and detect the presence of atmospheres around all 7 TRAPPIST-1 planets. Although the data revealed that the planets do not have large, puffy, hydrogen-rich atmospheres, the telescope was not sensitive enough to detect smaller, thinner atmospheres such as Earth's. And this is where the James Webb Space Telescope comes into the picture. When a planet passes in front of its star in our line of sight, we observe a dip in starlight. By analyzing the light curve, scientists can infer the presence of a planet around a distant star. This is known as the transit method. It's the most straightforward method to discover exoplanets. However, this technique not only allows us to confirm the presence of an exoplanet but also provides valuable information about its atmosphere. As the planet moves across the star, its atmosphere can modify the star's light that passes through it. By analyzing the changes in the transmitted light, astronomers can learn about the composition and properties of the exoplanet's atmosphere. This is where the Webb telescope becomes an invaluable tool. Optimized explicitly for studying exoplanet atmospheres, Webb can compare the filtered transmitted starlight with the unfiltered one to gain insights into the chemical makeup of these distant worlds. Webb is currently the most advanced telescope equipped to detect the molecular signatures of various compounds, including methane, carbon dioxide, and oxygen, within an exoplanet's atmosphere. Moreover, given that TRAPPIST-1 is situated in our direct line of sight, it provides an exceptional opportunity for the telescope to capture the transit of its 7 planets across the star's disk. Webb has already caught its initial glimpse of the TRAPPIST-1 system, and the first observations have confirmed that TRAPPIST-1G does not possess a hydrogen-rich atmosphere. Nonetheless, this is only the starting point. Webb is slated to observe the TRAPPIST-1 system in the upcoming months, focusing primarily on TRAPPIST-1e, which lies in the middle of the habitable zone and is closest in size to Earth. Additionally, observations of TRAPPIST-1d and TRAPPIST-1f have been scheduled to provide a captivating comparative sample. While multiple studies have already been conducted on the TRAPPIST-1 planets, searching for their atmospheres remains a top priority. In 2018, a study suggested that some of these planets could be rocky, while others may be wetter than Earth. Later, in 2021, another study proposed that the planets were likely rocky, although less dense than those in our solar system. Nonetheless, detecting atmospheres around these planets would have profound implications for exoplanet studies. Since these planets are situated so close to their star, their atmospheres may have been dramatically altered by tidal locking. And some scientists speculate that they may have lost their atmospheres to solar flares. Webb is expected to shed light on these speculations and provide critical insight into the habitability of these fascinating worlds. Exploring the atmospheres of rocky planets is a crucial step in understanding their habitability. The composition of an atmosphere can provide valuable insights into the geological and biological processes taking place on a planet's surface. For example, oceans, plate tectonics, and life can all affect the cycling of carbon, nitrogen, and oxygen in a planet's atmosphere, leading to different atmospheric compositions. Studying the atmospheres of Venus, Earth, and Mars in our solar system has provided valuable information on why Earth is habitable while the other two are not. Similarly, studying the atmospheres of TRAPPIST-1 planets is expected to yield a wealth of information about the habitability of other Earth-like exoplanets. Lastly, TRAPPIST-1 is a relatively young star, about 500 million years old, which means that planets orbiting it would have had enough time to develop life. So, the TRAPPIST-1 system is a fascinating target in astrophysics, and the James Webb Space Telescope is poised to reveal even more about this intriguing star system.